Hello everyone. I welcome you all to the ninth session of Data Analytics with R. I am Khitishwari Mishra, your instructor for today. We are discussing so far the basic programming techniques or the programming fundamental techniques which is there in any programming language and it is there in R too. So already we have listed out, discussed so many building blocks of the R programming. Those are constants, variables, data types, operators, control structures, functions, and data structures. Till now, we have discussed regarding constants, variables, data types, and operators. So today we'll be discussing regarding the control structures. So let us go to control structures. Now the question comes that what is control structure? The structure that controls the normal flow of the program is known as the control structure. That means here the question comes that what is the normal flow of the program? So suppose there is a program and the program is written like this. The first line, statement 1, second line, statement 2, third line, statement 3, and so on. Okay. So the control, the normal control, program control, first executes this line. Then after it finishes execution of the first line, it executes the next line. Then after it finishes statement 2, it executes the third line. So normally the program control flows from top to down. The approach is known as top-down approach. Top-down approach. Okay. But it happens well with very small programs. But whenever you have a very bigger program and after reaching certain level, suppose let's say I will reach at statement number 4 and there I need to perform some statements or a group of statements. Let us sum it as statement block. That means it has so many statements and I need to perform this statement block of statements, but I don't need to perform it directly after statement 3. That means I need to decide first that whether there are favorable conditions to perform this block of statements or not. That means I should move to this statement block only if a condition is satisfied. Condition is satisfied. If the condition is not satisfied, the program control should move from this statement 3 to the next block. Let's say the fifth block. And it will continue afterward. But to execute this statement block, I must satisfy a particular condition. Then in normal condition, it cannot happen so. So for that, in the programming structure in many programming languages, control structures are built. Control structures are made so that they can provide the technique, they can provide certain tools so that you can jump from one place to another place and transfer the program control directly. So these structures which controls the normal flow of the program, that means that they can shift your control, they can shift the program control from one place to another place directly with us. So These kind of structures are known as the control structures. So what are control structures? The structures that control the normal flow of the program, which is top to down, are known as control structures. Okay. Let us now go to the concept that how the control is transferred. Okay. So let us know about the types of transfer of control. There are two ways to transfer this control. First, you can transfer the control unconditionally. That means you need not test the condition, rather you can directly shift the control from one place to another place. It is a very dangerous operation and it leads to the shift of many statements. It leads to absence of many vital statements in your program. So it must be done with proper check. So unconditional transfer of controls can happen. That means in that case, you don't need to check the condition. You can just transfer the program control. There are structures. And what are the structures? The structures are break statements, next statements, and so on. Another way of transferring the control is to transfer the control conditionally. That means that is known as conditional transfer of control. So here you get two ways to transfer the control. First one is unconditional transfer of control and second one is conditional transfer of control. In case of conditional transfer of control, the control can only be transferred when the condition is satisfied. The condition must be tested. And based on the trueness or falsehood of the condition, the block of statements must execute. That means the control must go to either the true block or the false block. So in this type of transfer of control, a condition is needed to be tested. Then only the shifting of control can be possible. In case of unconditional transfer of control, we can do breaking and continuing. That means this kind of structure, this type of structure, there is a control structure. The statements are performed like this and it reaches certain point here where it will just go out of the scope. That means till now we have studied regarding the single line statements to perform. We are performing single line of statements. But now after this knowledge of transfer of control, we will get to see that there are certain blocks of code. And this block of code, when performed together, and there is a need to transfer the control out of the scope. This is known as scope. This curly bracket starting and end, this is known as the scope. This is known as the block of code. Block of code. And a unconditional transfer of control statements can transfer the control from this place to out of the scope. That is possible through break statement. Similarly, they can also continue and skip the current execution. So inside this block of code, you can also make a continuation, skipping the current execution, skipping the current block of code. Okay. So in this case, you can have unconditional transfer of control where there will be no conditions involved. Okay. In case of conditional transfer of control, we have three type of structures. First one is decision making structure. Next one is branching structure. And third one is looping structure. We will go to the detail of all these structures in the forthcoming slides. In case of conditional control structures, we have three types of structures as we discussed just now. Decision making structures, and those are if else, if else, and nested ifs. Branching structures include the concept of switching. Switch is a keyword. And in case of looping, you have three types of looping structure: for, while, and repeat. I will go to the details of individual structures. Don't worry. Let's move to the next one. So the first one is decision making structure. So types of if. If is the decision making structure, and there are four types of if: simple if else, if else, and nested if. I will discuss each one of it properly. You just mark here. In case of simple if, you can see here, program execution starts from the top, and when it reaches at certain statement where a condition is needed to be tested, if the condition is satisfied, then if the condition is true, then it executes the conditional code. Then it executes the particular code. Otherwise, this conditional code will not be executed. That means if the condition is false, then it returns out of the scope and executes other statements after this conditional code. Okay. So in order to execute this particular conditional code, the condition has to be true. And this is written with simple if. So here the condition is tested with the help of if statement. Okay. How it is written? I will go to the detail of all these structures in the next video, where I will go give you the syntax of simple if else and all. But let me tell you here, the simple if structure is like this: if, then within bracket you have to put the condition, then you can give the parenthesis, you can give the curly braces, you can start the curly braces, and you can write the conditional codes, the codes, the different statements that is based on this condition, that is needed to be performed based on the trueness of this condition. So these codes has to be written within this curly braces. This is called as the scope. This is called as the scope. And this is if block. If block. Okay. Starting from this point to last. This is if block. And whenever the condition will be true, you see, after reaching this particular place, condition is true, then it performs the conditional code and moves further. And if the condition is not true, it will go to directly out of the scope and do not perform this conditional code and moves to the rest of the codes. So this is simple if. Similarly, what is if else? In this case, we don't have any provision to execute any block of code in the falsehood of the condition. So in that case, you don't feel simple if to be sufficient enough. So in that case, you have to move to if else. That means in this structure, when the condition is true, you can execute certain block of code when the condition is true, and when the condition will be false, then also you will get to execute certain block of code. Okay. So in both trueness and falsehood of the main condition, you get to execute two different block of code as per requirement. Okay. So that is called as if else. How it will be written? It will be written like if condition, starting curly braces, then some statements, then and else, then else block will be started and some codes will be executed. So in this case, you will get to have two different set of block of code can be executed based on the trueness of the condition as well as the falsehood of the condition. Whenever the condition will be true, if block will be executed. When the condition will be false, else block will be executed. So this is called as if else. Next type of if category is if else. So how they will be performed? How it will be there? So in the earlier case, we have only one condition to test. But in this case, when the number of conditions are more, that means if the first condition is not satisfied, if the first condition is true, you can perform certain block of code and you can go further. But if it is not true, it is false, then you should not end, or you should not execute or reach at the conclusion that nothing can happen and move further. No, you need to test another condition. You see, another condition is written over here. So based on the falsehood of the previous condition, you can test another condition, and then if the condition will be true, you will get to have another conditional code to perform. And when this conditional code will be performed, you can go to the rest of the code. But if this condition is will not satisfied, that means this condition is false. Again, you need to test another condition. And then if it is false, then another condition. If it is false, then another condition, like this till the end, till you find nothing, no condition is satisfied. So you can reach up to the else part. Else is the final part. So you can go for the first condition. If it is not satisfied, you can have many conditions with the help of else ifs. Many else ifs you can have, and after that, if no conditions given in else ifs will be satisfied, you can execute the last one, that is true else. That means all previous conditions are false, so else block will be written. So you can perform n number of sets of codes, conditional codes, based on n number of conditions. Okay, so this is known as if else. Okay, now let us go to the fourth category of if, that is nested if. Nested means there is if within if. That means in case of if else, we are performing the condition checking based on the falsehood of the previous condition. But in case of nested if, we test the condition 1. See, this is the first condition. Program control transfers from top and reach this place where I will test the first condition. If it will be true, then also I will check another condition so that I can check that whether it is true or not. Then if it is true, then you can perform some statement. If it is false, you can perform some other type of statement. So in case of trueness of the first condition, the parent condition, we can have some child condition inside it. So similarly, not only in trueness, but also in falsehood, if the condition 1 is not satisfied and it is false, you should not enter directly to the else part. Rather, you can test another condition in the falsehood and execute certain statements based on its trueness as well as falsehood. And finally, go to the rest of the code. So in this case, you will have if structure within another if structure and within another if structure and so on. So you can nest the if blocks within themselves. So that is known as nested if. Okay. So I will give you a glimpse of this nested if structure. That means if, then condition will be written, condition 1. Within the block, you test another condition with another if block. Let's say condition 1, 2. Within the block, you perform some statements, end it, and then end the main if. So in this case, you are nesting condition, this condition under the trueness of this condition. So you are performing if within if. Okay, so that is known as nested if. So this can happen in trueness of the condition as well as in falsehood. That means whenever you have the else part of this condition, like here, you have else, you will close here and you will have the else part, and then inside else also you can test another condition. Let's say condition 2 and perform certain codes over here. So you can nest another if block within the parent if block. So this kind of structure, if structure, is known as nested if structure. Next comes your branching structure. Don't worry, I will go to the syntax of each one of it, and I will demonstrate everything in the next video. You just understand the concept. Okay. Next, we will go to the branching structure. Branching structure is known as switch. So what it does, in earlier cases, as we have already seen in if else, when the first condition is not satisfied. Condition means the conditional expression is a logical expression. Logical expression means it is a relational expression at the root and combination of relational expression. So that means suppose A is equal to 2 and now I want to test that whether A is less than 10 or not. So the relational expression A is less than equal to 10 or not. This is a conditional expression. As because it gives the output as either true or false. So this becomes a logical expression or conditional expression. Conditional expression. Okay. So whenever we use a relational operator, we get to have a conditional expression. So what are the relational operators we use generally? Less than, greater than, less than equal to, greater than equal to, equal to, and not equal to. We have studied in the previous lecture. So all these relational expressions we have studied. And when we use the logical expression like and, single ampersand, double ampersand, single bar or double bar, so and or operators, these are also are helpful to create the conditional expressions. So through this, among all these operators, this particular operator checks for equalness. Equal. Suppose I will write A equal to. That means A, the value of A is true or not. So it may have true or false if it is tested with if. That means the value of A is tested with, is compared with true. Similarly, if we have a bunch of statement where I need to test this value of A with certain value, with certain constant, then what are the condition I will make? I will make A equal to, A equal 3 or not, A equal 4 or not, like this. So that means every time the condition, the value is A, the variable name is A, and there are different values to test with it. Okay. So in this case, I will not go for condition checking. So in this case, the expression will be A and the cases will be 2, 3, 4 and so on. So this is called branching. This type of structure represents branching. And in this case, I will not use the if structure. I will use the structure known as switch. I will use switch. How to use switch here? I will use switch, SWITCH, and the expression, okay, and then curly braces start, and I will write the cases. So first case, and I will perform certain statements. Second case, case 2, I will perform certain statements and so on. Okay. and I will perform the default case else. Okay. So this is called as switch. Don't worry, this syntax I will give you in the next video, in the next lecture. So you don't need to be worried about it. My main motto is to make you understand for what purpose branching structure is used. Okay. So here, as as this diagram says, that here you have to write the expression here, and for different cases you can have different conditional codes to perform, and finally you have the default case, and you perform the default conditional code and go to the last, go to further. This is known as the branching structure. Okay. Next comes your looping structure. So in conditional transfer of control, we have found three types of structure. First one is decision making structure, which is if, and we have four types of if there. Then comes the branching structure, and that is your switch. And next comes your looping structure. So looping is a special case of conditional transfer of control. Why? Because it transfers the control upward against the natural direction of the flow of the program. What is this? How it performs this kind of thing? Let us know. The meaning of looping is looping. Looping means repetition. Repetition of sum. That means I need to perform certain tasks repeatedly. For example, I need to print 1, then 2, then 3, then 4, then 5. Well, how to do? Suppose I will write I is equal to 1. Then I need to go for print I so that it will print 1. Then I will make I is equal to I plus 1. Then I will again print 1, print I. Then I will again make I is equal to I plus 1. And then again print I. So like this, I have to repeat these two set of statements, print I and I is equal to I plus 1, many a times. How many times? The more number of times I need to print. So here I need to print 1 to 5. So I need to repeat this two set of code, two set of statement 5 times. So here I need to perform this 5 times. Think about the bigger program where many tasks are needed to be repeated many number of times, let's say n number of times. So you cannot write all these codes repeatedly. So to avoid this repetitive task, we use looping. We use the looping structures. What happens? You see, in this case, program control flows downwards. First it will execute this statement, then it will execute this statement, then it will execute this statement, then this statement and so on. But instead of going from this statement to this statement, if by some means it will transfer the control upward to this particular statement, then we don't need to go down. Okay, so this is a special case. Normally, the program control flows downwards. Top to down is the normal flow. But in this case, we need that your control should be transferred upward to certain place. So this is a special case of conditional transfer of control, because this looping structure, if I use a looping structure here, it will transfer the control from this place upward. So that's why it is known as the special case. Okay. Now, looping involves three basic steps. Looping involves three basic steps. First one is initialization. That means you must start with a value. Here you can see that we have started I is equal to 1. This particular statement is known as initialization. Initialization. And then you need to check the condition. Without condition, your repetition will be infinite. You can repeat the particular statements infinite times and your program will halt. So you must check it with a condition. And the third thing is iteration. That means you need to iterate one by one, line by line. So here we have I is equal to I plus 1. This kind of statement is known as the iterative statement or iteration statements. So in this case, if I use a looping structure, let's say while, I will tell about this in the next slide. So if I use while then condition and within the block of code, I will write like this. Then you will have initialization, condition and iteration. This is iteration. Let me write it properly. I is equal to 1, then while, then condition is I is less than equal to 5 and curly braces start. Within that I will print I and I is incremented 1, I is equal to I plus 1, right? Close. So in this case, this is initialization. This is condition checking. And this statement, I is equal to I plus 1 is the iteration statement. Okay. And this block of code starting from this to this are the looping block, loop block. Okay. Okay. Now the loops are either entry controlled or exit controlled. This means that the condition is checked at the entry point or exit point. If the condition is checked at the entry point, then it is known as entry controlled. If the condition is checked at the exit point, it is known as the exit controlled loop. So in case of entry controlled, condition is checked at entry point to the loop. In case of exit control, the condition is checked at the exit point. That means coming out of the loop. While coming out of the loop, the condition is checked. So in that case, it will be known as exit controlled. So depending upon where the condition is checked, we can call it as the entry control loop or exit control loop. Now by seeing to this particular structure, the while loop structure, I can very well tell that while entering into the loop, the condition is checked. So that's why this particular type of loop structure is entry controlled loop. Okay. Let us go to the different loop structure to understand it properly. See, we have three loop structure. First one is for, second one is repeat, and last one is while. In case of for, you see, it will enter the loop structure without any condition. For each element, that means after initialization of the first element, it will enter the loop and it will process the element. How long it will process? Till the last element reached. So it will check for whether the last element is reached as the end of the first occurrence. So after that, if the last element is reached, then it will stop. Otherwise, it will, if it is no, if the answer is no to this condition or false to this condition, it will go on executing the loop block. So in this case, this will happen, the initialization will happen before it, then it will start execution and do all kinds of iteration, and then it will reach to the condition at the end, at the exit point. And if it is true, if the last element is reached, then it will come out of the loop. Otherwise, it will again enter into the loop to perform the rest of the statements. So like this, it will continue. So which type of loop structure it is? It is exit control because it will test the condition at the end. Next comes your repeat. In case of repeat, also the initialization will be done first, then it will enter the loop, repeat loop, and then inside the conditional code you will have the condition checking. And for this, repeat doesn't provide any kind of uh, condition checking method. You need to employ the if block inside the repeat block to test the condition. And if the condition is true, it will break. It will come out of the loop. And if the condition is false, then it will go on executing the conditional code. So this is also one type of exit controlled loop. Now comes the while loop. We have already discussed with example the while loop, but let me tell you again, initialization will be done at this point, initialization. It will start from a point. So the starting point, the statement which defines the starting point is known as the initialization statement, and then it will test the condition first. See, the conditional block is first encountered. Then if the condition is true, then only it will enter the loop. It will not enter the loop code, the conditional code, without testing the condition. So whenever the condition will be true, then only it will enter the loop block and perform the conditional code till it satisfies the condition, till the trueness of the condition. Whenever the condition will get false, it will just come out of the loop. Okay, so this kind of loop structure is known as entry control loop. Okay, so by this time we have already discussed regarding the conditional transfer of control. Okay, so in this class we have covered the control structures and we get to know about different transfer of controls. Like first one is unconditional transfer of control and second is conditional transfer of control. Unconditional transfer of control structures can be done by breaking out of the loop or continuing unconditionally. And conditional transfer of control can be made through this conditional control structures such as decision making structure which is if, branching structure which is switch, and looping structures which are for, repeat and while. So in the next class, in the next lecture, I will give the demonstration of all these things with syntax and with examples.